Jupiter is so huge you could drop more than 1,300 Earths inside it. And that's just the beginning. Prepare to have your mind blown as we explore how massive the planets in our solar system really are. Have you ever tried to picture the size of the planets in our solar system? We live on Earth, a world that feels gigantic beneath our feet. But compared to other planets, Earth is tiny. In this video, we're going to simulate exactly how many Earths could fit inside every planet. From rocky worlds like Mercury and Mars to the gigantic gas and ice giants like Jupiter, Saturn, Uranus, and Neptune. We'll break down the science behind these astonishing differences, reveal the math that makes these numbers possible, and show you what it would actually look like if we could stack Earths inside these massive worlds. Stay tuned. What you're about to see might just change how you see our cosmic neighborhood forever. When we talk about putting Earths inside another planet, we're talking about volume, the amount of space a planet takes up, not its mass or weight. A planet's volume depends on its radius, distance from the center to the surface, and is calculated using the formula for the volume of a sphere. Let's start with our home world. Earth has a radius of about 6,371 kilometers, which gives it a volume of roughly 1.083 billion cubic kilometers. This number becomes our baseline, one Earth. Closest to the Sun, Mercury is a rocky world with a radius of just 2,440 kilometers, less than half of Earth's. Because volume scales with radius cubed, Mercury's volume is only about 5.6% of Earth's. That means you'd need nearly 18 Mercury-sized planets to equal the volume of one Earth. Or looked at another way, Earth is vastly bigger than Mercury. Humbling thought. If Mercury were a tiny marble and Earth a basketball, that might actually be accurate in volume terms. Next up is Venus, often called Earth's twin because of its similar size, but appearances are deceiving. Venus has a radius of about 6,052 kilometers, just a hair smaller than Earth, giving it around 85% of Earth's volume. So you can't even fit one Earth fully inside Venus because Venus itself is smaller. Venus's atmosphere is thick and hostile, but its sheer size is a reminder just how similar and yet how different it is from our world. Mars is about half the radius of Earth, around 3,390 kilometers, which gives it about 15% of Earth's volume. In other words, you could fit roughly 6.7 Mars inside one Earth. Mars might feel big when you see it in the night sky, but compared to Earth, it's a dwarf. Now, things get insane. Jupiter's radius is about 69,911 kilometers, more than 11 times Earth's radius. But because volume scales with radius cubed, that leads to a truly staggering number. You could fit approximately 1,321 Earths inside Jupiter. Imagine Earths stacked together like tiny beads, filling the interior of Jupiter. It's a simulation that makes our world seem microscopic by comparison. This isn't just theoretical fluff. NASA's Juno mission has given us detailed measurements that confirm Jupiter's immense size and volume. The simulation you'll see in this video uses real scientific data to make these comparisons as accurate as possible. NASA measurements. Saturn looks big, especially with its iconic rings. And it is. With a radius of approximately 58,232 kilometers, Saturn's volume works out to about 764 Earths. That's more than enough to make your head spin more than half a thousand Earths. But Saturn's density is lower than water, meaning if you could place it in a giant cosmic bathtub, it would float. Despite being so large, its composition makes it relatively light for its size. The outer solar system's ice giants are smaller than Jupiter and Saturn, but they're still massive worlds. Uranus has a radius of about 25,362 kilometers, giving it a volume equal to about 63 Earths. Neptune, slightly smaller at 24,622 kilometers, has a volume around 57.7 Earths. These planets might not look as strikingly large in diagrams as Jupiter or Saturn, but they dwarf Earth nonetheless, especially when you see them visualized in simulation. So here's the challenge. Can we intuitively understand these differences? Most of us grew up with solar system pictures, flat or side-by-side diagrams, and they don't show real scale. Even images that show size comparisons can't capture the staggering volume differences between terrestrial worlds and gas giants. We'll try to bridge that gap with a visual simulation one that lets you see these differences in motion. You'll see Earth shrink inside Saturn's huge interior, and then shrink again inside Jupiter's colossal volume, a scale that's nearly impossible to imagine without visual aid. Why volume matters? We compare volume, not mass, for two main reasons. Volume tells you how much space is inside the planet, a direct measure of how many Earth-sized spheres could fit in. Mass is a separate concept. For example, Jupiter is over 300 times more massive than Earth, but because it's mostly hydrogen and helium, it still has a lower density than smaller rocky planets. Point 2. In our simulation, every planet is shown to scale using volume. When Earth appears tiny next to Jupiter, that's not artistic exaggeration. It's real science. Let's talk about what this looks like in our simulation. Mercury and Mars barely make a dent. Earth nearly dwarfs them by comparison. Venus, while close in size, still doesn't quite match Earth's volume. As we move outward, the planets suddenly explode in size. Saturn, Uranus, Neptune, each one hundreds of times the volume of Earth. Finally, Jupiter stands alone. More than 1,000 Earths worth of volume. This isn't just numbers. When you see this in motion, it becomes intuitive. Here's the mind-blowing part. Jupiter alone could hold more than 1,300 Earths inside its volume. Saturn could hold more than 760. Uranus and Neptune can each hold dozens of Earths. That means if the entire Earth were somehow chopped up and stuffed like marbles into Jupiter, Saturn, Uranus, and Neptune, we'd still have worlds left over. Put another way, Jupiter greater than 1,300 Earths, Saturn greater than 760 Earths, Uranus greater than 60 Earths, Neptune greater than 57 Earths, and the inner rocky planets, smaller than Earth, would fit inside Earth itself multiple times over. What we've done here isn't just compare sizes. We've reimagined Earth's place in the cosmic scale. Earth may feel huge when you stand on its surface, but compared to the giants out there, it's one of the smaller players. From Mercury's fraction of Earth's volume to Jupiter's ability to contain over 1,000 of our world, the scale of the solar system is breathtaking. If you enjoyed this visual exploration of planetary size, remember, we can apply this same thinking to stars, galaxies, and beyond. And each level gets even more impressive. And if you enjoyed the video, make sure to like and subscribe and check out the channel to find more amazing and new videos.